Well, good morning, everyone. Thank you for joining our academia webinar talking about 3D scanning, additive manufacturing, and how that's changing the world of education. So I have the privilege of hosting this today, and my name's Derek. I'm the UK sales manager here at Measurement Solutions, and we've been in the industry for the last 25 years. And throughout that period, we've seen a real uptake in education and how 3D scanning is being utilized. And today we have Tom Vine with us from Staffordshire University. Tom, is it Tom or Thomas? What do you
Tom.
prefer?
Tom will do, yeah.
Tom,
Yeah.
brilliant. So Tom, your role, and I'm going to try and get this right. You are a
Mhm.
technical specialist in immersive technologies. Do you
Yeah,
want to
that's
do you want
right.
to introduce yourself and tell me a little bit about what you do?
For sure. Yeah. So, hi everyone. Good morning. As I said, yeah, my title's quite a mouthful, technical specialist in immersive technologies. So yeah, I joined at Staffs as a games technician, and slowly that role's kind of morphed into this. So like I started playing around with some like VR hardware. We opened our smart hub, um, which involved all kinds of things. So yeah, VR was part of that, and 3D scanning was another part. Which a colleague who left a few years ago to work at Vicon oversaw. And yeah, now that responsibility kind of fell to me. Um, yeah, as part of that building that smart hub, we got the HandySCAN Black Elite like pretty much as soon as it came out. I think we had we were going to order the one just before, and they came to us and just said, "Yeah, we've got this brand new one coming out. Would you want that instead?" It's like definitely.
Yeah, brilliant.
Yeah.
So you're obviously utilizing quite a lot of different technologies within the university. And you mentioned your smart hub. What does that entail? What
Mm.
does it look like from a technology point of view?
Um, yeah, so it's kind of divided into a few different areas. So downstairs we've got our 3D print facilities and things more based around sort of engineering and kind of like prototyping, physical prototyping, things like that. And then up here, kind of on the corridor that the room I'm in, we have the scanning rooms on one side, and we've got VR rooms on another. Yeah, so this is our main sort of scanning room. You can see I've got like a bunch of like test things that we do. So if so I'll do sessions introducing the scanner to students. And yeah, we've got a bunch of test objects to scan in just to show them kind of the differences of how you scan different things, the limitations of it, and the things that it's really good at, like yeah, reflective things and see through
Great,
things.
great,
Mhm.
great. Um, so yeah, we kind of one of the opportunities that we have today is for you to sort of share some of the things that staffs do. And I know that you kind of, as we've been talking up to this webinar, you were mentioning that you're obviously very involved with your students and the projects
Mhm.
that they do internally. But then also towards like the second bit of this webinar, it'd be really great to share some of your external use cases. I know that as a university, you're really involved with the community and with engineering firms and things like that outside of kind of educational grounds, which will be really great to hear about. So maybe
Yeah,
we
for
can
sure.
start off with potentially some of your kind of internal use cases and how you seeing it, the technology being used within your courses and the kind of stuff that students bring to you on a day to day.
Okay, sure. Yeah, I'll give a tour around. I've got a few things prepared. So yeah, let me just share my screen. If I just pick. Cool. So can you see that?
Yep,
Sharing
that's
my
brilliant. That's coming through.
yeah. So I've got everything kind of imported into Blender here. These are all scans from the HandySCAN Black Elite, exported as STLs or FBX or whatever they were needed as, and yeah, just imported them into Blender and clean them up a bit to show off. Um, so yeah, one of the first things we did, like the scanner was kind of involved more with more around engineering at first, because that's kind of yeah what its use case uh, sort of presented us as. So this was yeah with Chris Wayman's groups, and they were creating key fobs for cars, their own designs, and yeah, I believe their goal was to scan them in. I'll get them 3D printed first, and then we scan the 3D prints and they would kind of take those back into whichever CAD packages that they use and try to reverse engineer those. So yeah, that was yeah, several groups came in, or I think individuals, each with their projects here, and yeah, just scanned in these little key fobs. So that's kind of one of the
That's,
kind of like the core things that we did like every year. Yeah.
So that's quite an interesting. So you're immersing two technologies together. So you got 3D printing, 3D scanning,
Yeah.
bring them into sort of a digital content. I have the amazing privilege of, hosting you guys this morning is not just like, this is awesome, but it's doubly awesome for me simply because I went to Staff's uni,
Oh,
and
sure. Yeah.
you're talking about Chris Wayman there.
Yeah.
He's been around for a while now, and some of the course content that I remember doing during my design degree involved, and this is going back a few years now. I'm starting to get a little bit more grey in the hair and things like that. But we're going back to sort of 2007, 2008. I remember even then using 3D scanning as part of a design modeling kind of module, looking at taking I'm just trying to think now. Going back there, it was a hand sander at the time, and kind of modeling that, and then 3D scanning it,
Mm.
uh, reshaping it using haptic devices, as well as resurfacing the data, and then 3D printing it as a finalized product to then finish and present as a prototype model. And that one module alone has been definitive in my career going forwards. That kind of technology is what I'm involved in now. Is one of the things that made me excited about 3D scanning. It made me excited about printing and the
Mm.
kind of immersive technologies that we're seeing come through now. Um, Apart from sort of an engineering background, are you using scanning in any other sort of way? I can see some more examples
Oh,
here. Great. So I'm going to
for
shut up
sure.
and let you go for
Oh
it.
yeah. No worries. So, yeah, yeah, that was early on, and it's kind of developed. So these are more sort of group projects with just a kind of different thing that they're scanning and sort of reverse engineering these pump housings. Just wanted to show that quickly. Well, yeah, I move on to some of the more um, out there things that we do, or just things that we would maybe didn't expect 3D scanning to kind of branch into, um, for it to be, yeah, so useful across so many different areas. So it's kind of an early one that I thought was quite interesting, because it was kind of a challenge to get yeah, a fashion student who wanted to scan um, yeah, this mannequin, which is, yeah, like it's not like a life size one, it's like 20 centimeters across, and she wanted to kind of take the sort of chest part of it, make a chest plate so that she could 3D print that and yeah, do fashion designs around that sort of fixed plate. So we did this scan, just focusing kind of on the front bit that she wanted to recreate. And then, yeah, I had to learn some Blender. Yeah, I didn't know too much about making things in 3D at this point. So a bunch of tutorials and methods of cleaning up the scan. And this is what I kind of came out with something that was thick enough to 3D print. And yeah, it turned out fantastically.
So this is so you obviously taking sort of your B surface, creating an A surface, and then kind of offsetting to create a thickness for the plate. And in terms of like a body armor example, I've seen this a lot myself within the kind of MOD world, where you're looking at creating very bespoke body fitting armor.
Mm.
So really relevant. It's interesting you're doing it from a fashion point
Yeah,
of view.
sure.
Who says body armor has to be boring, right? It can
Yeah,
look good too at the same time.
definitely.
What So you say you 3D printed it? Did you print it in any sort of particular material or?
I'm not sure. I'm not too sure about that. The 3D print guys are the kind of experts on that. It was probably a PLA one. I don't think it was a resin print that they did. Um, yeah, I kind of do my job and just send it down to them. And if there's any kind of issues with it, they send it back up for me to fix. Like, yes, this is the early one. There's some weird sort of defects on some parts of it. So a lot of this was
So
to do with like retopologizing it.
sort of in terms of your kind of CAD
Mm.
background, your day-to-day kind of work, is Blender one of the main software programs that you utilize?
Yeah. In fact, I have no CAD background at all. I like barely ever touched it. I wouldn't know how to work it if you put it in front of me. Um, so I come from like a games background.
Okay.
or actually more of a, like a game scripting background. I did game design and production here at Staffs, and joined here pretty shortly afterwards. Yeah, as a games tech. But yeah, my background's kind of more scripting based, but over the years I've kind of picked up more 3D knowledge, and yeah, it's kind of amazing how applicable that is across so many areas. Just having that kind of 3D tool set just enables you to do a whole lot.
Yeah, and it's I think kind of my experience over the last couple of years is that often when people think about 3D and utilizing 3D data, it can be quite a scary prospect.
Mm,
But actually, it isn't. One of the beauties of 3D scanning, especially from a sort of games design world, is that you aren't necessarily starting from scratch when you're doing your modeling and your design work. So you're actually able to scan real life objects, bring them into a data environment, and as you
mm,
kind of just shown on that fashion example, very quickly take some not so usable information, but turn it into something that gives you a final product at the end. And
yeah,
great example, self-taught in Blender, which is an awesome modeling program for very heavy in the games industry,
for
used a
sure.
lot in that, but actually very simple to go from A to Z with a complete model at the end of it.
Yeah.
Um,
Um,
do you have any examples from that industry, maybe perhaps? I'm not, I'm kind of
oh, for sure.
sure you have a lot to share. I mean, you've got a couple of years of student projects coming through your door, so it'd be cool to see what
Yeah.
else you have.
Yeah, I'll go through a couple I've got as kind of extra here. As okay, this was with one of the VFX lecturers, and he just wanted to scan kind of like a realistic military glove, that he could then obviously take into like ZBrush and clean up, but also rig and animate it for use with virtual reality. So you would use yeah, so you would use this. This would be the representation of your hand in a VR experience. So yeah, a few considerations for this, because obviously it's a flexible material that would be kind of hard to scan from multiple angles because its form would change. Um, so we stuffed it with tissue to keep its form, and tried to keep the fingers separate as well, so we could rig up the fingers, so that they would animate and not kind of web into each other.
Yeah.
Yeah, so that's quite interesting. The problem with a lot of these, I don't have like the end result, because that often doesn't come back to me unless I specifically ask for it. But I remember this turning out really well and seeing it in
Yeah,
VR.
and so I think one of the big things you've just highlighted there is like preparation of
Mm,
the item you're going to scan is appropriate. Also, the kind of materials you're going to be scanning, whether it's reflective. You mentioned that earlier on in the webinar.
mm,
Reflective objects traditionally used to be very difficult to scan.
yeah.
Um, Kind of the newer blue laser technology that's out from Creaform helps to resolve that. You don't have to spray your surfaces, and you're able to scan them. But I mean, what's quite impressive with this scan, which I really like, is actually the level of texture and detail that you're seeing. You've got all of your stitching marks, your kind of grip marks,
Mm,
and that from a games point of view would have been quite a lengthy thing to try and work out and model, right? So
yeah,
you're
definitely
almost doing
getting.
that ahead of actually getting it into a VR world, which is awesome.
Yeah, quite a lot of everything. The requests we get from games are things that definitely save them a ton of time for, kind of awkwardly shaped surfaces, especially if they conform to something flexible. Or just the textures on them, even, they will just, rather than use as a mesh, they'll use that as kind of a normal map for their
Yeah.
for the
Yeah.
texture, so they wouldn't have this as actual mesh detail in the game, because it has to be optimized so it'll run fast enough. So you would bake this into a normal map, which would make it look bumpy, but not the actual physical surface it isn't. So yeah, there's a lot of smoke and mirrors in games that you kind of get from this.
I mean, in terms of file size, because what's quite impressive at the moment is you've got multiple different files open,
Mm.
loads of different scans there. Do you want to just walk through how you take a scan like this and turn it into a usable asset within a games world, kind of later down the line?
Um, sure. So getting the raw scan from VX Elements. It's often useful for it to be watertight because that makes it a bit, yeah, it makes it easier to work with and apply certain modifiers to it. If I was to take something into Blender that I wanted to turn into a game asset, I think one of the first things I would do is decimate it either by adding a modifier here or go into the actual mesh itself. I won't go into edit mode because it'll take ages to load in.
So
um,
decimating is reducing the triangulation count of the scan,
yeah,
but trying to maintain as much detail there as originally was scanned. Yeah.
yeah, yeah. So any kind of flat surfaces will get sort of reduced down in polygons. So yeah, so rather than having millions of vertices here, it'll try and make them as flat as possible, which is obviously easier when you've got an actual flat object. But yeah, reducing that down is good. Although a lot of the time things need to be retopologized to use in games, especially if you're animating them. Because kind of this, oh, sorry. Yeah, so this dense detail isn't ideal for it in these sort of random triangulations. So you want something more uniform. Um, I'm not sure if like the glove is maybe not so good of an example because it kind of needs that detail. But you could make a more basic form around it and do what I was saying with the baking the normal map onto it. You would have something simpler that looked more like the bodice, the chest plate earlier, where there was kind of squares on it, like uniform squares.
Yeah, I get you.
Um,
I get you.
yeah.
Because you obviously when you're animating, you're looking at all the joint positions,
Mm.
and having a bit more of a basic shape where you then that's critical to those joint movements. Obviously,
Yeah.
all the
So you've,
baking that you're talking about afterwards is that's an additional process that happens, but you've got to
for
have the
sure.
form and structure first to start it. But
Yeah. Was that another one? And this one's a more in it's game related. Uh, this one. Yeah, it's a scan of a PS5 controller. This was done by one of our VR students, who part of their VR course is kind of scanning and recreating things for like realistic objects to have in a VR environment. Um, so yeah, we did this scan, which turned out well. Um, did it high detail. Obviously, some issues on parts where these buttons are kind of glassy, so you get a lot of noise there. Um, but yeah, solid mesh to work with.
so
But the student, oh sure,
for, so sorry, Tim. So from a VR point of view, so what you're sharing there is taking
mm,
a digital asset, putting into virtual reality. Obviously,
yeah,
with the kind of progression of the metaverse and VR headsets in general, and the way that's coming, it's quite interesting that you're taking that and putting it from a scanning direction
mm,
rather than modeling from fresh.
yeah.
And yeah, I mean, just looking at the screen
I think
now, that's a
yeah,
seriously cool example of
yeah, the
yeah.
results are incredible. This yeah, this student's kind of yeah, he pretty much excels in whatever he does. But he sorted out the materials fantastically on it. Like it pretty much looks like the real thing. And using that 3D scan data as the base of that just allows him to, rather than like model these odd curves from scratch, you get something that doesn't quite look like the real thing. Yeah, I'm wondering if he combined this with photogrammetry or if he just created the materials kind of
I mean,
from scratch
yeah,
as well.
either way, that's a really impressive model. I can
Mm,
see Ellis Rogers. Great job, mate. Very, very
sure.
impressive. So using just from a display point of view, this is Sketchfab, is that right? That you're using at the moment to view the
Um,
model?
oh yeah, this is on his art station. I assume this is like
It's
a sketch. Yeah, this
ArtStation.
is
Okay.
sketch. Yeah, it's a Sketchfab link or embedded thing.
Yeah,
Yeah.
one of the questions we often get asked is, if I do a scan, how do I share it with my clients, or how do I
Mm,
share it across other universities, or especially from a research point of view, how do we take that data and share it across with my colleagues in the USA or that kind of thing? We know we do a lot of work with museums and heritage, and
mm,
taking that really critical digital data and sharing across is quite important. And one of the websites I use, which it looks like Ellis is using here for sharing his link of his work, is a website called Sketchfab, which is free. You can
yeah.
you can sign up, you can load your models, you can share that asset, you can even sell it. It's a virtual store where you can buy models and things like that. And it's really amazing the kind of stuff that people 3D scan on a day-to-day basis, either for work or just as a hobby thing, or you name it. And the kind of interest that it generates from everybody else um, for those models. So that's a really awesome example of taking a scan into a final rendered model. So yeah,
Yeah,
well done, Ellis. If you ever
absolutely.
get to watch this, mate, great job.
Yeah. That's it. Um, that's a pretty good segue into uh, some of the other things I've got prepared. Mentioned this the Spitfire in the description for this webinar, so we could move on to that if you
Absolutely.
want.
I'm
Pretty good.
I've got a little caveat here, right? So
Mm,
um I may not sound English. I'm not. I'm originally from South Africa, but
mm,
my grandfather is a Geordie. Can you believe it? And
mhm,
in World War II, he flew Spitfires. He was a
mm.
squadron leader, and I, long history behind that, but he was shot down in Holland and survived, and there's this amazing history behind it. And so Spitfires has a special place in my heart, mate, which
Ah,
I'm trying to say. So
yeah,
yeah, let's hear about it, because I think your external work is just as interesting as your internal stuff that you do
yeah,
with the university.
absolutely. Yeah, it tends to be quite a lot grander. um, but yeah, I'll share that because yeah, after scanning it, it's got kind of a special place in my heart as well.
Brilliant.
Yeah, so I managed to combine it all finally. Just kind of the raw scans. Um, but yeah, this took probably about 5 or 6 days total. We did it with the Black Elite, so we had to put those markers all over it every time we scanned it. It was initially I thought it was kind of silly to do, like we should probably do this some other way. I think we tried with the Faro focus first, but yeah, just didn't quite capture it right because this is where the Spitfire is. It's in a big room with like glass windows all around, so the lighting kept changing. And yeah, since it's kind of image based, I couldn't get anything to align with it. So we went in with the HandySCAN and just tried to capture it in as good a detail as possible. We used like the 1mm resolution, though to get it loaded in here, I've decimated it down a bunch.
Yeah,
uh,
big file, I
yeah,
bet. Yeah.
yeah. I think the most I could get together in one VX Elements session was this. So I've had to export them out, decimate them, align them in Cloud Compare, and then recombine them here in Blender. So this is like one of the scans would have been just the bottom of the wing, and that would have almost like capped out the RAM on the laptop we've got for the scanner here. So yeah, new file, top of the wing. Make sure we've got enough overlap on it. Um,
It's a
yeah.
you kind of, there's two things I've just picked up on there. So the first one was, you mentioned using other scanning technologies such as
Mm,
lidar based systems, um, and one of the things that is often very important to consider when you're looking at 3D scanning, and even if you bring it into your own university or into industry, is considering the application and the requirement for what you're actually wanting to measure or scan. And
yeah,
often you can kind of pick the wrong tool for the job, and your experience there of trying it with the lidar and finding that the lighting environment's a problem.
yeah, for
um,
sure.
and also kind of your level of detail. A lidar might not have that level of detail that you can pick up with a handheld laser
Oh,
scanner.
absolutely. We wouldn't get all the rivets come through on it. Yeah, that's for sure.
And that just takes a little bit of experience. And I think,
Mm,
what's really important in that kind of scenario is talking kind of your experts that do it, but then also, as the more you scan, I'm sure with this approach here with the Spitfire, you would have very quickly picked up the HandySCAN as your first choice
mm.
when you do it again. Do you want to just talk me through the kind of, obviously being commissioned to do this? How has that come about? What was the idea behind scanning the Spitfire?
Um, I think we'd had projects with the museum, the Potteries Museum up in Hanley here in Stoke. It's so we had the VR students had a task to scan various artifacts from that museum before. So we brought in things like gas masks and old like medical boxes and things like that. And yeah, part of their course was scanning those in various ways and then reconstructing them. And actually, those went back into the museum, where they have a like a touch screen, which has these digital recreations of them that the students have
Amazing.
made.
Yeah.
Yeah, so that's all in the same room as this Spitfire. Um, and I think, yeah, something just led on to them doing this, and they gave us a bunch of money for it. This was all organized by the uh, one of the VR course leaders at the time, Yankorenko. Um, yeah, and he got us in there, scheduled these scanning sessions with this, and I believe he took the data in the end and produced something for them. So I've just kind of picked up what we had, because again I never got the final thing from him, and just kind of put it all together here, mostly out of interest, but also, yeah, something really cool to show off in this
Yeah,
webinar.
I mean, it's very, you kind of forget the scale, don't you? Looking at
Mm.
literally a small screen and a little model, like it's like,
Oh,
oh,
absolutely.
that's great, but actually, this is a full blown uh, plane, which is really, really incredible. And I think what I love hearing about this example is how Staffs is giving back to the surrounding area. And I think, Staffs Uni was, I think you established sort of 1906 around sort of mining and science and things like that back over 100 years ago.
Yeah, it was a
And so to
polytechnical or
have,
something. Yeah.
yeah, and it's really amazing to see how Staffs has developed over the last sort of 20, 30 years, especially once it became an established university. And the
Mm.
kind of, students that you have coming out of it. I'm one of those students. My wife
Mm.
was one of those students. And it's amazing to see how you guys are driving virtual reality and sort of these immersive technologies to the forefront. And in examples like this, critical from an heritage point of view,
Mm.
using the data to share with other museums, but also preserving that heritage of what was a Spitfire back in
Yeah,
World War II. Really important historical piece of information, which will now be forever stored. Um, whatever happens to that plane doesn't matter. There will be a digital copy of that plane somewhere now in existence, which is
yeah,
fantastic.
absolutely. I'm not sure I'm not sure a higher resolution scan of a Spitfire exists, to my knowledge. I'm not sure if anyone else has done kind of the same thing. I think that was kind of the what definitely Jan was excited about to do. Is like, yeah, no one else is probably no one else is going to have done this. Um, yeah.
Yeah, super exciting. And we do a lot of aerospace stuff ourselves, and
Mm.
I've had the privilege of working on some of the Red Bull air racing series, where they're kind of racing planes of this size. Obviously, not Spitfires, because that'd be crazy to do that. But looking at smaller planes, MXS specials, etc. And um, one of the use cases we found through that was actually creating that digital record with all the surface data allowed you to do fluid dynamics and basically your wind flow over the plane. And one of the hardest things in aerospace is working out your plane. If we're not talking about a car, right? There's complexities around Formula One, for instance, of a car driving around a track.
Mm.
But you're always driving around in one axis, right? You're always driving on a surface. You're never going to go up and down. And when you introduce planes and you introduce the complexities of airflows and temperature and the fact that you're in a full 3D environment with 6 degrees of freedom, having data of your aircraft becomes really, really important to be able to work out your airflow dynamics.
Yeah.
Is it the most efficient if you have your wing flap in this position or in this position, that kind of thing. And so, um, yeah, there's so many use cases. What's exciting that I'm enjoying this morning is seeing all the different examples you're bringing from just a couple of examples
Yeah.
already. Yeah, it's fantastic. It's fantastic.
Sure. Yeah, could show because we do quite a bit with automotive as well in here. So I think I'm just gonna just go through a bunch, whichever ones I've got kind of left, just to have a
It
gander
sounds
in.
like we've prepared this, but we haven't, right? We
Yeah.
just we should just go. That's brilliant, mate.
Yeah,
Okay.
I've just kind of cherry picked what I thought was the kind of the most interesting ones. I mean, this is kind of, I guess, one of the more standard requests that we get from automotive is just scanning a certain part of something so they can get a measurement. So I think they wanted to put like a battery sort of rack or bay or whatever in here. So yeah, just to scan this, all they cared about was the distance between these things. Move on, I've got another one. Some other.
Whilst you're
Yeah,
whilst you
just
whilst you're whilst you're bringing that up, and
Mm,
I got actually Chris dropping some comments in the chat, and one of the things he was mentioning is using your scans for creating DXF profiles. So you're actually doing laser cutting straight off scan profiles, which is quite an interesting thing, and we see
okay.
this more and more often. Taking 3D back into say inverted commas 2D world, but actually having that digital slice through data, especially when you're looking at freeform surfaces, very hard to measure, isn't it? Trying to, I'll give you an example here with a car.
Mm,
How you measure all those fluid dynamic shapes on across the surface is very difficult to do in a traditional method. So to have a 3D scan allows you to take it that step further. How you use the from an engineering point of view, and how you use the data. So
mm.
carry on, Tom. Where does this come from?
Sure. Yes, this is our Formula Renault they've got down in one of the automotive workshops. We've got half a scan here. Because yeah, the project was it was a game student who wanted to scan it and recreate it as an accurate 3D model of a car in a game. So we only needed half of it because he would clean up one half of it and then just mirror it uh, for the other half there. So we just wanted kind of the chassis and then some of the more technical bits at the end which are much harder to scan because everything's kind of occluded by struts and pipes and things like that.
Yeah,
Mhm.
yeah,
But
that's quite impressive. I think in the chat, Chris is talking about CFD analysis for this example, and
mm,
um, you think about Formula One in general. They've been using scanning for the last, oh goodness me, I'd say 20, 25 years or so. It's been integral to the way they've designed cars, the way they analyze their cars, and we've been really privileged to be able to work with. I think we're in five or six of the top teams in the UK who use Creaform devices, and yeah, it's amazing the kind of use cases you see. CFD is one of them, but actually whether you're scanning a driver, checking for FIA positioning, or you're looking
mm,
at um, tire treads, or even one of the kind of when I saw the example, I was like, I can't believe nobody's done this before. Like kind of scanning the track and actually using that as a way of, is your track smooth? Is it rough? How does that
uh,
affect your tire choices? And bringing that into the foreground when you're doing your wind tunnel testing. And there's so many different uses that come off the back
mm,
of scanning. And F1 as an industry itself has really kind of pushed that technology, especially also on the 3D printing side, almost as far as it can go. But they're still going, right? They're still using it. And
yeah,
I love the Formula E student course that runs at Staffs there, because I've seen the car in person. It's really really impressive.
yeah.
And just how do you every year do you is there a team that comes in and rebuilds the car and redesigns it, or how do you manage that kind of
Um,
workflow?
I'm not sure on the specifics of it, but yeah, it's definitely a point of pride um, with our technical specialist over there, Martin Dunn. Yeah, every year he gets the students together, teaches them really well how to sort of build this stuff. I've like no knowledge of it really, but they come back with awards through the work they do. Um, yeah, just really solid. And yeah, it's always great working with them and scanning whatever they need to get scanned so they can refit things, measure things, and add new components or whatever however they need to customize it. Like yeah, you got us to scan just an engine block, so we got the dimensions of that to put in somewhere. I always thought that was a really cool scan.
Yeah, so you're scanning the full car as well as all the piece components, which
Yeah,
which makes sense, right? You're creating a digital record of the piece components, but using that as part of your design workflow. And like things like an engine example is great. Like as simple as, will this engine fit in the car, right?
mm, yeah,
Rather than physically having to try and do that, you've got two digital copies. You can kind of mimic that in 3D before you even get to fitting it in. We had a very
yeah,
similar example with, um, although not automotive, but Natural History Museum, when they put the new blue whale skeleton that's hanging up in the main hall, the main atrium there, and they
right,
replaced the Diplodocus. That was all done with 3D scan data prior to actually hanging it up on the rafters, because one of the things they couldn't do is just test it. They couldn't just drop it, like hang it
No.
off the ceiling and hope that it's going to hold, right?
Yeah.
So they actually took scan data, scanned this whale skeleton. I mean, the cranium bit, the top bit of the mandible was like 26 foot in size. It's huge. The scale is
Mm.
massive. And then they utilized that data, applied a material condition, worked out the weight of it, put it in its diving pose, and then basically said, okay, is this going to work from a theoretical point of view? Does
Yeah.
the mathematics stack up? Is there enough safety factor when we're hanging this thing onto the rafters? Can the museum handle the weight? So they did all of that prior to even doing the physical fit, and then obviously they came to physically fit it, and it's fantastic. But they've now got a digital record of that whale they can send around the world. But
Mm.
great example of using data ahead of the physical work that comes afterwards.
Yeah,
I
that's awesome.
I I see you also had a bike there, which I had a
Oh,
sneaky
yeah.
peek of. Be awesome to see that.
Yeah. Oh, there it is. Yeah, I think this was just sometimes we just go in and just demonstrate the technology that we've got, and we had some students that were interested in bikes, and yeah, we just scanned a bike just because it would be cool to do, and just show them, yeah, what it's capable of. Again, yeah, what it's good at, what its limitations are,
Well,
like how much you
that's
need to construct.
and that's
But
quite that's quite an amazing scan as well, because you've got, I'm guessing, quite a lot of different surface materials over that. Because I can see you've scanned the mirrors and things like that, which is really
yeah,
impressive from a technology point of view. So
yeah, for sure. Um, yeah, I think like certain instruments scan really nicely. Obviously, yeah, mirrors don't come in so well, but you get kind of enough to know where the surface is, which is always
mm,
good. And yeah, anything kind of glassy, it just kind of goes through. Um, yeah, I think the challenge was with this one was scanning it all and keeping the front wheel aligned with it. So we had to kind of scan that. Yeah, had like a separate scan where we could align it by the fork and cut out the rest so that we wouldn't have any weird like overlapping, misaligned stuff. And kind of the same with this other one that I definitely want to show before we run out of time. Is this is another external company who are designing a motorbike, and they brought in this frame which I believe they built from um, a CAD model of a Chinese design. So they built this frame and then wanted to scan it and compare that to the CAD model to see where the kind of from the manual labor their defects were or anything was off, and then again use that and use the dimensions that they've got from that scan to create the like the shell of the bike around it. And we've got a really cool,
oh wow,
yeah, they come
yeah,
up with a
yeah.
really cool cyberpunk looking bike. This was awesome when they brought it in.
Is
This was
that
just like last week.
is this an electric bike? Is it, or
Yeah, electric bike. So yeah, you've got the big battery box there. So they've kind of designed it all around that battery box and used other measurements to kind of change the wheels. I think yeah, we've got the other fork they brought in with a different wheel, which I think they hope to implement it will integrate onto the bike based on
quite a
this scan data that they've just got.
nice spoke design, that one, right? It's I do like that one.
Yeah, yeah, the tire looks really cool too.
It's something interesting that we are seeing in the sort of EV world. Obviously, there's a huge adoption of electric vehicles and
Mm,
the technology behind it, but actually we're seeing a real growth market in sort of your heritage vehicles. So taking heritage vehicles, which are becoming harder and harder to maintain just because of parts shortage, right? I mean,
yeah,
that's one use case for 3D scanning as is, but what we're seeing now is requests for taking those heritage vehicles or vintage vehicles and turning them into electric versions. So kind
sure.
of kind of taking out the gas element of it, and turning it fully electrified. And
Yeah,
we've had the privilege of doing some work with Ed China from Wheeler Dealers. Now everybody knows Wheeler Dealer. They know Ed. This guy was like the engineering genius from a design background as well, which is awesome. And he's done a lot of work of taking classic vehicles and converting them to electric. And I think his first project was, in fact, an ice cream truck of all
right.
things to pick, right? So he's made an electric ice cream truck, which kind of
Yeah,
makes sense, right? From a driving around your estate and selling ice creams, awesome, awesome project. But
sure.
3D scanning has become really important in his workflow. You know, traditionally you have to tape measure everything up and
Mm,
pencil and ruler and set square and try and dimensionally work it out and then do a bit of CAD work. What he does now is actually 3D scans. So in the example where you've got a frame there, well, is my
mm,
battery going to fit in there in the first place? Well, let's scan the frame and then digitally fit it to see if it will actually fit inside the aperture, and then build your kind of your shape, your frame, your shell frame around that, which is
mm.
brilliant example. I really like that one.
Yeah, also, yeah, because they're going to make tweaks and redesigns from this too. And just to go back to what you're saying about like vintage cars, that's kind of the Formula Renault. We did one before as kind of a test to see like how feasible that was. It was came from one of the games lecturers who has a collection of classic cars, and he just wanted to, yeah, figure out how he could scan those and you know get like a digital backup of them, I guess, or just digital recreations.
Yeah, I think like sort of digital copies of things become it's becoming really important. And you know, if you think of a using the heritage example again, if a car is crashed and it's a one-off vehicle, it, to be able to reconstruct that back to its original state,
Mm,
unless you have some sort of information of that vehicle, is near impossible. And so
for
we're seeing
sure. There's no CAD data for it.
exactly, yeah. We're
Yeah.
talking about something that's hand beaten and paneled together from
Mm,
like 100 years ago or whatever. There was that technology wasn't available, and we're actually seeing now like kind of even to the point of you sell your car at auction, right? And what goes with the car is a digital record of that vehicle. It creates a traceability of whether that car's been in an accident since it was last purchased, like where's the damage occurred to it, has it changed shape, like on all these different things that come into play by having a digital copy, which goes with the vehicle. And from an insurance point of view, insurers love it, right?
mm,
It's the utopia of, well, did you crash it or not? No, you didn't.
yeah.
Okay, great. Let's move it on. Amazing, Tom. So some awesome examples there. I'm really privileged to see those. Um, from a course point of view, so you've mentioned fashion, games,
Mhm.
design, bit of engineering. Are you seeing 3D scanning used in other areas of the university?
Oh, sure. One of the other big ones, yeah, probably second to engineering is ceramics. So obviously,
Well,
yeah,
you
stone,
are in the
stone,
potteries, mate. So
yeah, we're in the potteries,
so
of course. So, yeah, it's kind of hard, impossible to avoid. So I didn't have it actually. This is kind of the example I got prepared of what students mainly use ceramics for. But like recently we've done scanning at the Brampton Museum because they want digital recreations of some of the like antique pots and cups and things that they've got. But ceramic students will come in and they'll have ideas for uh, they want to kind of recreate a surface like a natural surface and use that as molds for their ceramics. So they'll come in and they'll scan something of some often really interesting shapes, um, take those to 3D print, um, blow them up, and then
mm,
use those as different surfaces for whatever it is their project idea is or what they want to make. We get some really odd stuff, some natural things, and then things that have seemed kind of like mutant crumpets. I think there's some kind of plaster thing going on. Um,
it's the top of an oat
yeah,
cake, is it?
it's
Or,
really it's yeah, yeah, it's very oat cakey. Um, but it's quite a lot. We get requests like that.
it's quite an interesting use case, isn't it? Because
Mm,
like that kind of process in the past would have been a lot of plaster Paris and a lot
for
of
sure.
kind of trying to get the imprint.
I think you would just need to
So
use like your kind of artistic ability to recreate because these are obviously very small, but they want to blow these up to what 20, 30 centimeters to use as like the basic form of
mm,
something.
mm.
So like reverse miniaturization.
No, very cool. And like from a ceramics point of view, it's really interesting. I think
Mm,
you're talking about blowing stuff up, but also scaling down, isn't it?
yeah.
We taking an object like that, scaling it down and producing jewelry out of it is also a
Mm,
really kind of interesting spin-off. And I think with all of these examples that you're sharing, there's this kind of there's one key element which is you need data, right?
Yeah.
You need a scan to start off with, and if you have a scan, a lot of the work is reduced by having that digital copy in your
Mm,
hands in the first place. Um, and ceramics, you think you're taking what was a very skilled manual job
mm.
and making it a lot simpler, and also in some ways even more exciting. I mean, I'm really impressed by your spiral tape there.
Sure.
It's just cool, just a cool
Yeah,
idea from like,
that
what
was
could
a
we do? Yeah,
that
it's
was a painter scan. That's metal, was like shiny metal.
amazing.
I'm amazed it came
Yeah,
out as well as it did. Um,
a great example.
yeah, yeah, it's taking this data and basically creating new pipelines for it, and like kind
Amazing.
of revitalizing technology that's goes back thousands of years.
Yeah, yeah,
Um, how there's still innovations in something so ancient. Yeah, it's really interesting, and it's not just taking stuff to 3D print; it's digitizing and combining that with stuff like virtual reality and creating digital galleries of things, or combine it with augmented reality and seeing, uh, yeah, seeing it's like these things superimposed in the real world.
yeah. And you've kind of just, went straight into my kind of last question to hop
Mm,
around itself is where do you see it going next?
mm,
Virtual reality is a big one. Augmented reality, you've been able to virtually see, like we have examples, especially in the kind of marketing world or online world, where you can actually take a picture of your room and drop a 3D sofa into your room and see, like, is that going to
mm.
fit? Is it the right color? Is it, that
Yeah.
kind of thing? So, yeah, you've kind of touched on a little bit. Do you have any more thoughts on where you might see your 3D scanning used in the future?
um, I think I could see it. Yeah, people having ideas for it. Um, I, so far, it's been everything that's come to me has been kind of a completely new thing with its own challenges to figure out, because people just have ideas to use this as like, oh, if I have this data, then I can use it in this certain way. And I think, um, like as 3D literacy kind of improves and becomes more widespread, because obviously, ceramics folks don't have this kind of digital 3D background
Mm,
traditionally, but and now it's starting to become something more and more relevant. People will start picking up tools like Blender, which is easier than ever to do. I mean, it's free, and the resources there to learn it are, yeah, there's loads, and much more intuitive and everything as well. So I think as
yeah,
people start picking this stuff up, they'll be able to find more possibilities with it, and I think we'll just see loads of unique projects from all areas. Yeah, not just visual arts ones, but things like so we have forensic archaeology. We've used it recently. I'm not able to show the example we have, um, but yeah, 3D scanning in that area is obviously a big deal, to get like super accurate representations of things that may not last, or that reveal more truths to them, like things that you can't read. Like we had some graffiti where people had scratched their names into it, but you can't read them like with the naked eye. But with a
mm,
3D scan, then took that into Unreal Engine and applied a material to it to make it easier to see those little engravings, and we managed to make out the names of them. Obviously, that's it
amazing.
was kind of a sensitive topic. I can't show that,
Yeah,
but
no,
yeah,
no,
it's a
that's
really
okay.
interesting
But
process.
As an I mean, as an example though, I mean, it's great, and I think what's interesting in how Staffs is approaching it and seeing the way you're using 3D scanning. I think traditionally a lot of universities might put 3D scanning into a box and
Mm,
it's only used in that one specific subject. What's amazing with the stuff you guys are doing is
mm.
actually you're applying it to so many different areas of teaching
Yeah.
and deployment, but then also you're obviously reflecting what is happening in industry, and that's what we see. Like
Mm,
predominantly it's heavily used in automotive and in aerospace, but actually the use cases. I mean, some of the stuff I've been involved with personally, and our team's been involved with, like, would just blow your mind. Like, you would
mm.
never have thought of using it for that application until someone says, can it be used for that?"
Yeah,
And you're like,
absolutely.
yeah, maybe. And then you work through the process and you're like, this is fantastic. And I think for me, I've not often seen repeat projects like you do in your traditional industries, but it's 90% of the stuff I do is new stuff, which is really, really interesting. So, um,
Sure.
I'm conscious of time, Tom. We're heading towards the end of the webinar, but it's
Sure thing.
been super informative. Thank you so much for spending an hour with us and sharing what you guys are doing.
Yeah, I've really
Um,
enjoyed showing off all the interesting things we've done. Like I said, it's always a unique thing. Our our technical services policy is open access for everything. So yeah, it's only just fed into what we've been able to do and the kind of things that have come to us. And I'm really glad to show that.
and if there'll be people that kind of that's on the webinar now that will be watching this later on social media and stuff like that.
Mm.
Who's the best person to contact if they want to come to you for some work to be done, or they have questions about your course content, etc.?
Um, sure. I mean, you can contact me directly. I don't know if you want to share like my university email
Yeah, we
around
can
it.
we can we can
Yeah,
do that afterwards. Yeah, that's fine. Yeah,
sure.
great.
But it's thomas.vine@staffs.ac.uk. But yeah, could share that around afterwards. Yeah, I'm more than happy to respond to requests and direct you to the right people. Yeah, I should about to. We do have like an external work thing where we figure out like how much it might cost to get some scanning done for an external company. But that's a possibility to use our facilities. But yeah, students and staff here can use it for free.
Great. Yeah. Well, that's another way to get access, isn't it? Sign up to
Mm,
Staffs Uni.
yeah, absolutely.
If you're looking in, looking out, looking in, thinking, "Oh, should I join Staffs?" Yes, is the answer.
Yeah,
Brilliant, Tom. Thank you so much for your time. Um, I am looking through here. I don't think we have any sort of questions come up, which means that you've done an excellent job, mate. You've covered
fair play.
absolutely everything there. We will be posting this online afterwards. If you have questions for ourselves, the Measurement Solutions, so we're the hardware provider for the Creaform HandySCAN that Tom's been talking about today, you can obviously drop us a line or jump onto our website at www.measurement-solutions.co.uk. And yeah, feel free to send us an inquiry, and we'd love to help you. But Tom, thank you for your time once more, mate, and have a
Mhm.
great weekend.
Thanks for having me. You too.
Cheers.
See ya.